Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure of phenyl benzoate. Phenyl benzoate is C6H5COO6H5. It has two rings, the acyl, benzoyl, ring bearing the COO group as a substituent, and the phenoxy ring bearing the OC group as a substituent. Moving on to the next step. Determine directing effects on each ring. Acyl, benzoyl, ring, the COO group acts as an electron withdrawing group, meta-director, through resonance and induction. Therefore, electrophilic bromination on this ring would give predominantly the meta-product. Phenoxy ring, the oxygen of the ester is directly attached to this ring. The O lone pairs donate electron density into the phenoxy ring by resonance, making the oxygen an ortho-para director and activating the ring toward electrophilic aromatic substitution. The phenoxy ring is therefore more reactive than the acyl ring. Moving on to the next step. Determine which ring reacts preferentially. The phenoxy ring is activated by the oxygen, electron donation via resonance, while the acyl ring is deactivated by the carbonyl. Electrophilic bromination will occur predominantly on the more activated phenoxy ring. And for the final step, determine the position on the phenoxy ring. The OC substituent on the phenoxy ring directs ortho-para. Para substitution is favored over ortho due to steric effects. Therefore, the major product has Br at the para position of the phenoxy ring. Match two options. Option D shows the unsubstituted benzoyl ring connected via COO to a phenyl ring with Br at the para position. This corresponds to parabromination on the phenoxy ring. Eliminate other options. A. Br ortho on acyl ring, and wrong position. B. Br meta on phenoxy ring, wrong position. Meta direction would occur on acyl ring, not phenoxy. C. Br para on acyl ring, acyl ring is deactivated. Therefore, the correct answer is D. Therefore, the correct answer is option D.